Okay. Uh, Thank you for the science father, and thank you for the international research world on computer vision. I am Peixian Zhuang, associate professor from the University of the Science and Technology, Beijing. Today, I will share uh, a title named Unified Multi-Color Model Learning Based Deep Support Vector Machine for Underwater Image Classification, which have been published on Engineering Applications of Artificial Intelligence 2024. Our report include uh, the sections. The first is background. The second is the problem. The third is our proposed data sets. The fourth is our proposed model. The fifth section is experiment. The last is the conclusion. The section. As we know, the images are crucial in computer vision, serving the primary media for conversing vision information. However, the underwater image encounter more severe degrees intelligence compared with nature images due to the complexity of the underwater physical environment. These more serious quality degradations issues in underwater royal underwater, such as the color degradations, hence blur and low contrast and lower brightness. As unfortunately some higher quality quality underwater task tasks are series hampered due to these quality degradation issues, such as for the objection detection, living fish regression, and underwater species detection. Therefore, classifications of underwater images according to different degradation degradation categories for design efficient and accurate underwater image classification methods plays a positive role in promoting underwater vision tasks. For the problem, the first problem is the real-world underwater image classification datasets. Existing underwater image datasets are not collected and categorized in terms of the degradation properties of underwater images. Therefore, it is challenging to construct the real-world underwater image classification datasets according to the degradation the characteristics of underwater images. The, the second problem is the image features in multicolor models. Existing exi- existing most of the existing underwater images classification methods overlook the image features in multi-color models, resulting in the lower utilization of image features and a lower classification accuracy, such as these most methods focus on RGB color space only, including in overlooking the HSV or LAB, the color species. Mm, the the third section is our data sets. Data sets. lower light, lower light, lower light, lower vision and blurry details. The UCS is the second is the underwater vision blurry classes. For the called the UVB UVBCS. Two pairs from the left to the right are the to histogram distributions and underwater images derived from the general blur subset classes and the series blur classes, respectively. In terms of the vision perception, this class of the vision images are mean first with the series vision class detail loss and weak color casts. In terms of the histogram distribution, the histogram distribution of each color channel is unified and similarity and similar. Meanwhile, different the pixel pixel intensity of each channel is not apparent. The third is the called the use LLCS. Okay, two pairs are also from left to right. To right are the two histogram distribution of the underwater image derived from the local lower light subset and global lower light subset, respectively. In terms of the vision perception, this class underwater image mean faces weak color casts local over exploring global under exploring and a lower brightness. For the histogram distribution is uniform and constrained. Besides, the pixel intensity of each channel are mean constrained in the region of the lower green volumes. Okay, we also divide these three class datasets into the final classification subset, and their image numbers and their image hist numbers are listed as follows. The details of the underwater image classification datasets before or after enhancement. The fourth is our proposed method model. The flowing chart of our classification methods is listed as follows. Include the main steps. The first is the multi-color model encoder. The second is the deep support vector machine. The two main focuses respects for underwater classifications are the first, integration of the feature information with different representation ability. The second is the extraction of the rich feature information. And as shown, for the first in the first stage, multicolor model encoder, we divide the underwater image into three color species, such as RGB, LEB, and HSV. Then we put these features into the MCME, our multicolor model encoder, to extract the key features. In the second stage, we propose our deep support vector machine. We cascaded SVM cascaded VM to process these key features to get the features we want. It's showing that the channels are from RGB, LEB, and HSV, and the features also include the RGB, LEB, and HSV. Okay. For the 5-section experiment, we test. We show our setup. The first is the test dataset. We use our proposed UICD. These datasets include 6,630 images with a solution of the 32 with a solution size of 32 plus 32. We also compare our proposed methods with 2 machine learning methods and 8 deep learning methods. For the general evaluation metrics, we use the accuracy and ACC and mean square error (MSE) to test. Okay. For the first results, we first study the effect of the training and testing images with different resolution size on the classification. We study their effects. The image as showing the image size for 8, 16, 32, 64, 4, and 90, 96, and 128. 28. It as the table as shown in the table reports the effect of different image size with different solution and different regions of training samples on the classification ability of our methods. It is showing that our methods have the highest accuracy when the image solution is 32 plus 32. Okay. On the we also study the effect of different kernels sections for the classification capability for our proposed methods. We test on different kernel functions, including linear kernel function and the polynomial kernel function and Gauss radial base kernel function and a neural kernel function. At present, in these figures, the classification response to different kernel functions represent an overall increasing trend with the increase of the training samples. Notice our methods achieves the highest classification accuracy when they using the Gauss radial based kernel function. On the third results, we test our different methods on the classification results on rough classification tests. We it's showing that on the rough classification tests, our results achieves better results of the mean classification accuracy and the MSE results compared than other methods. We also investigated our proposed our form model with the following cases. The A is our methods without the RGB color model. The B, our methods without the RGB color model. The C is our methods without HSV color model. The D, our methods without the deep can cascaded model. And E, our methods without the bank Peixian optimization strategy. It is showing that our methods achieves best results when we using the full model. Okay, the last is the conclusion. Okay. In this paper, we propose a unified multicolor model learning supporter vector machine for underwater image classification. Specifically, we first introduce the challenging existing underwater image shaping methods to enhance different degradation underwater images. Further, we suggest that classification underwater images of different degradation types is instructive for design the underwater image classification methods for dedicated degradation categories. Then we built a large scale the real world underwater image classification dataset based on the degradation property of the underwater images. Meanwhile, we designed the deep support vector machine learning for rough and finer classification of the underwater images with different degradation categories or different degradation levels of the same degradation category. Finally, the final results, the experimental results demonstrate our methods have a better classification performance than the 10 representative classification methods. In summary, we list our three contributions as follows. The first is we built the large scale underwater image classification datasets based on the degradation categories and histogram distribution categories of underwater image, including 630 real underwater images. The UIC include the three types of the degraded underwater image with the color casts, vision blur, and lower light. The color class include the blue and green, and the blue green and caster subclasses. The vision blur classes include the general blur and severe blur subclasses. The lower light class include the local light and global local light subclasses. The UICB provides a valuation platform for different underwater image classification methods to some extent. This is the first contribution. The second, we propose a multicolor model encoder strategy to unify and enrich the diversity of capabilities of underwater image feature representation in different color models, which considers features information and of underwater image with a different collogram represents saturation and contrast in RGB, LAB, HSV color model. The second contribution. The last contribution, we propose a deep cascaded support vector machine learning for underwater image classes, which embed a unified multi-color model into the deep category network to unify the whole network model with a gradient descendant. Meanwhile, it resolves the sources of sufficient feature utilization and the lower classification accuracy of the single color model. Okay, that's all. Thank you for your teaching, and thank you for the science father, and thank you for the international research works on the computer vision again. Thank you.